we're actually going to learn some theorems, almost like geometry, but theorems that will help us to figure out the roots of the equations. We'll learn the rational root theorem, and then we'll also learn the irrational root theorem. So a polynomial equation has roots. A polynomial function has zeros. They are the same thing. So you can interchange the words roots, zeros as answers, or as vocabulary words. They're kind of interchangeable. So instead of asking you to find all the zeros, they're going to ask you to find the roots. Some of them they'll ask just the rational roots. So it says, consider the following equation. So I've given you this one. This one I factored for us. Okay. So what you want to notice about the factored form is that the terms that we're left with, 2, 3, and 4, the linear terms, those would multiply to get me 6 times 4, which is 24. Notice that that's the last term in the polynomial. Okay, I'm just helping you discover the theorem we're about to learn. That's all I'm doing right now. Now the next one, obviously a much bigger equation. As you can see, this would not be factorable by grouping because we don't have GCFs that could really be taken out. Now the next one gets you fractional answers. So, do we notice any relationship between these fractions and any of the numbers that we notice in the given equation? Notice any relationship between, and it could be split up into numerators and denominators. Looking at relationships between the numbers that we're given, because in this one we notice that the 2, 3, and 4 multiplied to get me the last term. This time we have fractions. Does anyone see an observation amongst these terms and any of the numbers that we see over here? Hannah?
The denominators add to the first term and the numerators add to the last term.
Multiply. Good. So the numerators, 1, 2, and 3, bless you, multiply to get me 6. 6 is the last term, which we call the constant. The denominators, 2, 3, and 4, multiply to get me 6 times 4, which is 24, which happens to be the first term. Okay? This is basically what the rational root theorem is going to tell us below. The rational root theorem tells us that we can list all of the possible roots. We're going to list every number that could possibly be an answer using the fact that the numerator will always be factors of the constant term, the last term. The denominator will be factors of the leading term, which is our starting number. So that's what this says in a whole bunch of math jargon. So it says if p divided by q is in simplest form, so talking about like something like this, and is a rational root, remember a root is also a 0, of the polynomial equation, again they give you some random polynomial equation with all variables, then it's telling you p, the top, the numerator, must be a factor of a0, which is the constant term. So the numerator is a factor of, let's just say, of the last term. But it's really your constant term, the one that doesn't have a number with it. And q must be a factor of a sub n, which a sub n was your first term. So this was our denominator, factor of the last term. No, first term. Now, rational numbers, remember, are numbers that can be written as fractions. Remember, our irrationals were like square roots and pi. So this theorem is only going to give us the answers that can be written as fractions. It's not going to get us the imaginary numbers, any square roots. It's just going to give us anything that would be a rational answer or a rational 0 or root to the function. So on the front, they ask us just to find the rational roots, which means we're not going to get 3 answers necessarily because some of them may be irrational or complex. imaginary, i's, square roots. But they want us to find any rational roots, something that can be written as a fraction. Now, in this instance, both of these are factorable by grouping, okay? Which normally we would factor by grouping and we could find our answers. But in this case, I want us to practice using the theorem to list all of the possible, and then we'll check and see which ones actually work. So the steps are listed right over here to the side for you. Step 1, identify the possible rational roots by using the theorem. Factors of the constant term over factors of the leading term. Okay, so possible rational roots. You do have to examine positive and negative factors. So, again, we're doing factors of the constant term in the top and the leading term in the denominator. So the constant term is 8. So factors of 8 would be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So this was factors of 8. That's my last term. In the denominator, I'm doing factors of the leading term, which is just 1. Which would be just plus or minus 1. And then technically, you would divide each of these by the denominators, but when you divide by 1, it doesn't change. So the possible rational roots are 1, 2, 4, and 8, positive and negative on all of them. Now, to figure out which ones actually work, technically you're supposed to plug them all in, okay? Which would take us a lot of times to plug in values, positive and negative, and check them all out. I'm going to show one of them. So let's do positive 1. And you're checking, does that equal 0? Technically you have to plug in negative 1, positive 2, negative 2, etc. We're going to use our graphing calculator to make this shorter process, but technically using the theorem, that's how you would do it. So 1 cubed is 1. We'll do all of our order of operations, so 1 squared is also 1. Multiply first, so we'll get 1 minus 4 minus 2 plus 8. And then we add or subtract in order from left to right. So 1 minus 4 would be negative 3. Negative 3 minus 2 would be negative 5. And negative 5 plus 8 would be 3. Since that does not equal 0, that means that 1 is not a factor. Okay? Again, technically you're supposed to test all of these, but we don't have time to do that. So we are going to use our graphing calculator to assist us. By typing this into our y equals, we can go to our table and see which of the values actually do equal 0 rather quickly. But if you didn't have a calculator, you would have to do it by hand, which I won't make you do, but just know that it is possible. So to check this in our graphing calculator, I'll go to my y equals and type in the function. You can go to the graph if you want and look and see if you can see where it crosses. But you also can go to the table and see if any of them equal 0, which you should notice that 4 equals 0. So graphing calculator, and I say check the table. That way you don't have to do second trace a bunch of times. So x equals 4 is one of my answers. 8 did not work, as you see in my table. So I'm going to scroll down and see if any of my negative 1 or negative 2 or negative 4 or negative 8 work, and they don't. So the only answer is, the only rational answer, is 4. There are technically 2 more answers, but they are either irrational square roots or they're imaginary. And the directions for this just say find the rational roots. Okay. Some of the directions on your homework will say list all of the possible roots. So make sure that you're not not paying attention to this part, because it is important, even though you can sometimes find it with your graphing calculator. So for this one, first let's list all of the possible roots that are rational. So this one we're going to do factors, again, of the last term over factors of the first term. So we're going to have factors of 5 over factors of 3. Last term over first term. So the factors of 5 are just plus or minus 1 plus or minus 5. Factors of 3, plus or minus 1 plus or minus 3. Now you have to actually divide those to get what your possible factors are. So the possible factors are then 1 divided by 1 is just 1. 1 divided by 3 is 1/3. Also go to the 5. 5 divided by 1 is 5. And 5 divided by 3 is 5/3. So those are the 8 possible answers that are rational. So now we have to check these either by hand or with our calculator. Of course, calculator is our preferred method. So we'll go there. Usually they won't be factorable by grouping. These ones were, actually, but a lot of them on the homework are not. So that's why I chose not to show it that way. But you could technically factor this by grouping and then find your answer using the zero product property. Now the problem with the table right now is that it counts by ones, right? So we're not going to be able to see the 1/3 and the 5/3. So you might want to go to the graph. You can change the table if you want. This is our window. If you notice above, it's table set. So if you wanted to, you can change the table. Instead of counting by ones, it can count by 1/3 if you wanted to, because these are all thirds. But some of you, once you change it, you don't change it back, and then you'll come to me like 2 months from now and go, "This is fun, I don't know why my table looks so funny." So you might not want to mess with it if you're not like a fan of the graphing calculator. So you might just want to look at your table, check out positive and negative 5. So negative 5's no. Negative 1's no. Positive 1's a no. Positive 5 is a no. So let me just go ahead and eliminate those. So now it has to be one of the fraction ones. So 2 options are, again, to change your table, or you can go look at the graph. Oops, I should have pressed in 6 first. Okay. Now, remember, the graph is going to show you rational and irrational answers. So you only really want the ones that can be written as a fraction, not necessarily a square root answer. So you're only looking for one of these. You may notice that it looks like it's at 1/3 just by looking at the graph. So you might want to just check it. Personally, I usually do adjust my table set, but some of you won't like that. So I'll go to my table set, which is second window, and the delta table is what you're counting by. So I would just change it to count by thirds, because this question talks about thirds. And then you should see that it happens at point 3 repeating. You get 0, so my answer would be 1/3.
Could you also do it if you hit like second calculate then a value and just like the x, like both the negative and the positive?
Yes, you can do that. So when you go to your graph, she said, can you press second trace and your value, which allows you to type in a value for x, you can type in 1/3. Now if your graph for some reason is not zoom, you might have to zoom out or zoom in to be able to see the picture. But yes, that's actually a really good idea, Abby. And then you can check all the other ones too. So second trace value, let's try negative 1/3. And you'll get 9.7, that's a no. And check all of them. Let's check 5/3 just to be sure. 5/3. No. So it looks like that's the only one that I'm getting. Sometimes you will get more than one, though. That is rational. Now on the back, they're going to change the directions. Instead of saying just find the rational roots, they want you to find all of them. So you're going to get all 3. Now, once you know one root, how can you remove a root from an equation? How can you remove a root from an equation to make it, instead of being a cubic, if I know one of my roots is 1/3, how could I remove it to make this now an x squared function? What operation would allow me to factor out one of my roots? You did this in 6.3 where I gave you like x cubed something and one factor, and I asked you to factor completely on your quiz. synthetic division or long division. So if you know one of your roots, you can divide it out. You'll then be left with no longer a cubic but a squared function, which is then either factorable or solvable using your quadratic formula. So on the back, again, pay attention to the directions on your homework, all roots this time, which means we should get 3 of them. Okay? Now, you do want to check and see if it's factorable by grouping. So this one is not going to be because you can see that there's no GCF amongst them. So if it said find all the roots, that's the first step I would do. If not, we're going to do what we did on the front. So we're going to list our possible factors. Which would be factors of 20 over factors of 5. So factors of 20 plus or minus 1. And if you want, you can just put 1 plus or minus at the front and then just keep going. 2 is a factor, 4 is a factor, 5 is a factor, 10 is a factor, and 20 is a factor. And again, all of those will get plus or minuses technically. And then factors of 5 are plus or minus 1, plus or minus 5. So then simplify this. Obviously, when you divide by 1, you get all the numbers as they are. But whenever you divide them by 5, you'll get fractions. So you would get 1/5, 2/5, 4/5. Now you will get 5/5, which is really 1, so you don't have to write it again. You already have 5 divided by 5 is 1. 10 divided by 5 is 2, which I already have listed. And 20 divided by 5 is 4, which I already have listed. So that should be all of my possible roots. And then you need to figure out, of those rational roots, which ones actually are roots to the equation. So we'll go to our graphing calculator so that we don't have to evaluate all of these by hand. And we'll type this into our y equals. And so the table is going to be the fastest way for you to quickly scroll and see without having to type each one in separately like Abby was talking about, but that works really well for the fractions. I'm glad she mentioned it. Now my table, again, I'm set back at my 1/3 because I messed with it last time. So I'm going to go back to my table set. I'm going to change my starting number to actual whole number, which it is, -1, and change my table, my delta table, which is what you're counting by, to 1, and then go back there. And you should see I had one of them here. Nope. So none of my whole numbers work. They're all eliminated. Not a single one. So it is one of my fractional answers, which this one's kind of hard to read. And it could be positive or negative with the fractions. So let's go to our graph, zoom to 6. And I like Abby's idea. Let's do our second trace value. And let's try one of them. Let's try 1/5. Nope. Try 2/5. So second trace, option 1. 2/5. Nope. Second trace value, 4/5. Yes. So x equals 4/5 is my only rational root. Now, what we're going to do next, we've done this, we've done this, we've done this, we've done this. Once you have found the root, you're going to use synthetic division to find the remaining roots. You're going to have to do synthetic division with a fraction. And you're using this with the original equation. So 5, -24, 41, -20. That's not going to be as bad as you think. So the 5 drops straight down. we multiply the 5 times 4/5. Now when you multiply 5 times 4/5, the 5's just divide out, because you would end up getting 20/5, which is just 4. Remember, you are adding downward, so we'll get negative 20. Take your negative 20 and multiply it by 4/5. Okay? Now you can multiply across and get negative 85ths, but you should notice that the 5 would divide out and make this a negative 4. Negative 4 times 4 is negative 16. Add downward to get us 25. Do the same thing again. 25 times 4/5. The 5 will divide out with the 25, leaving us with just a 5, and 5 times 4 would get me 20. You should always get a remainder of 0, because you know this is a factor, okay? If it's not 0, then you did something wrong. Now, throw back on, this is our constant, our linear, and our quadratic. So we have 5x squared minus 20x plus 25. Technically, this is equal 0. Now, you are going to want to try and factor this, but oftentimes it's not factorable, so you may have to use the quadratic formula. I would take out a GCF first if I were you, just to make the numbers smaller. But you should know it's not factorable because we had 5 wasn't a factor, 1 wasn't a factor. We tested all of them to see if they were, and none of the whole numbers worked. So then we would divide by 5 on both sides. So that still equals 0. Unfortunately, there are not factors of 5 that are both positive or both negative that add to negative 4. If this was a minus 5, it would be factorable. So we have to use the quadratic formula. I'm going to come over here to do that. We'll have x equals negative b, which would be positive 4, plus or minus the square root of b squared minus 4 times a times c all over 2. Okay? If you don't take out the 5, you would get much bigger numbers. It's still doable, you just have to reduce a lot at the end. So we'll get 4 plus or minus 16 minus 20 over 2. So I'll get the square root of negative 4 all over 2, which is then 2i. All being divided by 2. So you can actually divide each of these by 2 to get 2 plus or minus 1i, or just I. So our answers are 2 plus or minus I, and the one from above, bring it down. Those are my 3 answers. 1 rational, 2 complex. Okay? Now, when it just says find all the roots, on your homework, try to factor by grouping. The next one is factorable by grouping, I believe. Take out an x squared, take out a negative 5. The other one wasn't, that's why we didn't. We get x squared minus 5, x minus 2. And then you can solve easily. This one, you are finding all the roots. You're not just factoring now, we're finding the answers. So we use our zero product property. And we solve. We don't have to use the quadratic formula because we can actually just square root. So add 5 to both sides. So positive or negative square root of 5. And add 2 to both sides, x equals 2. 1, 2, 3, 3 total, because those are all of the roots. The next one, would it be factorable by grouping? the last one we see here. Take out an x squared, I could take out a 1, but it's never going to have a 3. So it's not factorable to begin with. So you would have to do the process that we did above, which is to list out all of your possible roots, figure out which one works, use synthetic division, and probably quadratic formula. I will do this one on the video, so if you guys want to watch it later, I'll do a part 2 video, so if you don't want to watch the whole thing, you can just watch this example. There is one in your homework, and your homework is on Google Classroom, 6.5, day 1. There is one on Google Classroom that you have to use synthetic division twice. I believe. Remember from last year. So if you were to get that 2 of the answers worked, you would actually do synthetic division once, and then you would do synthetic division again with the answer you get to divide out both of the roots to get you down to a quadratic. Because I think one of the homework questions is a quartic function. But if you're having trouble with the homework, as you can see, it's going to get more and more challenging as we go through. The problems sometimes take a lot of space. Please come in during homeroom. But I will do number 5 on an extra video for you guys.